Welcome to Pioneer's Knowledge Hub.
You might find it surprising to know that the core of a planet, including our very own Earth, spins at a different speed than its surface. It's a fascinating phenomenon, isn't it? This differential rotation, as scientists call it, occurs due to the dynamic and complex interactions between the solid inner core, the molten outer core, and the mantle. These interactions give rise to our planet's magnetic field, an invisible shield that protects us from solar radiation. Without this shield, life as we know it would be impossible. So you see, the core is not just a hot spinning ball at the center of our planet. It's a life-sustaining powerhouse that keeps our world safe and habitable. Now let's take a moment to ponder on this intriguing thought. What if a planet existed without a core? What would it be like? What could possibly happen? Welcome to the realm of the coreless planet, a world that defies our earthly norms. Imagine a planet without a core, a celestial body devoid of the metallic center we're so accustomed to. It's a theoretical concept that pushes the boundaries of our understanding, and yet, it's a possibility we cannot ignore. This is the coreless conundrum, an enigma that might reshape our understanding of planetary formation and existence. Now, what happens without a core? A planet's core is responsible for generating its magnetic field. This invisible force field shields the planet from solar radiation, acting as a stellar guardian against the sun's high-energy particles. Without a core, this protective shield vanishes. The planet becomes vulnerable to solar radiation, its surface bombarded without mercy, and that's not all. The core's absence also influences the planet's geological activity. On Earth, the core's heat drives the movement of tectonic plates, causing earthquakes, volcanic eruptions, and even creating mountains. In a coreless world, this tectonic activity might be absent. The landscape could be flat and static, without the dynamic shifts and changes we see on our home planet. But what about the atmosphere? Could a coreless planet hold on to an atmosphere? The magnetic field, aside from protecting us from solar radiation, also helps in retaining our atmosphere. Without it, solar winds could gradually strip the planet of its atmospheric gases, leaving it barren and exposed. Yet, while a coreless planet seems inhospitable, we shouldn't rush to conclusions. Our understanding of life is based on earthly norms, and life elsewhere might not play by the same rules. In a world without a core, life as we know it could be a distant dream. But is it a universal truth? Let's delve deeper into this fascinating conundrum in our next segment. Stay tuned as we continue our cosmic journey into the unknown. Let's put our Earth and this hypothetical coreless planet side by side. Now, imagine two planets spinning in the vast cosmic space. One is our beautiful blue and green Earth teeming with life, while the other is a desolate coreless planet. The contrast between these two is not only skin deep, but goes right down to the core, or the lack thereof. First off, let's talk about the magnetic field. Earth's core, a swirling molten mix of iron and nickel, generates a powerful magnetic field that shields us from harmful solar radiation. Without a core to generate this magnetic field, a coreless planet would be constantly bombarded by solar winds, stripping away any potential atmosphere it might have and making it a rather inhospitable place. Next, we have tectonic activity. Thanks to our planet's dynamic core, we have plate tectonics, which are responsible for creating mountain ranges, deep sea trenches, and even causing earthquakes. On a coreless planet, without the heat and pressure from a core to drive tectonic activity, the landscape would be static and unchanging. When it comes to the atmosphere, Earth's core indirectly contributes to its maintenance. The magnetic field it generates helps to keep our atmosphere intact, protecting it from being stripped away by solar winds. A coreless planet, lacking this magnetic shield, would have a difficult time retaining an atmosphere, if it could develop one at all. And finally, the potential for life. Earth's core, with all its heat and energy, helps drive the carbon cycle, a vital process for life as we know it. Without a core, a planet would struggle to support the complex processes needed for life to exist. As we can see, Earth's core plays an essential role in making our planet lively and vibrant. Without it, Earth would be a drastically different place, perhaps resembling more of a barren, lifeless rock than the thriving oasis of life we call home. The concept of a coreless planet opens up new avenues for exploration in planetary research. As we delve deeper into the mysteries of the cosmos, the study of coreless planets presents a fascinating frontier. It provides a unique perspective, a window into the early stages of planetary formation and evolution. So what are the potential areas of research? First, understanding the formation of coreless planets could offer insights into the birth of planets in general. These celestial bodies, devoid of a core, might represent an intermediate stage in planetary evolution. By studying them, we could unravel the processes that lead to the formation of a planet's core, and by extension, the planet itself. Second, the study of coreless planets could help us understand the role of planetary cores in sustaining life. Many theories suggest that a planet's magnetic field, generated by its core, shields life from harmful cosmic radiation. If we find life on a coreless planet, it could reshape our understanding of the conditions necessary for life to thrive. Third, coreless planets could have unique geological features that we have yet to encounter. The lack of a core might result in different tectonic activity, or even entirely new types of landforms. Exploring these could redefine our understanding of planetary geology. Fourth, studying the atmospheres of coreless planets could shed light on the role of a core in atmosphere retention. Planetary cores are thought to play a crucial role in holding on to an atmosphere. If a coreless planet possesses an atmosphere, it could provide clues about alternative ways planets can retain their atmospheres. Lastly, coreless planets could serve as natural laboratories to study the effects of extreme conditions on a planet. They might experience extreme temperature fluctuations or have highly irregular orbits, which could give us insights into how planets cope with such conditions. As we venture further into the cosmos, we find ourselves asking, could there be life on a coreless planet, or is a core an essential ingredient for life?
Please do like, share and subscribe to my channel. Thanks for watching.